Hi everyone, meteorologist Chester Lampkin coming to you from my home office in Auckland, New Zealand. Recorded this video on the 16th of June and we're here to talk about El Nino. Yes, it is here. It's back. We haven't had an El Nino for a few years and this one is forecast to be a pretty significant one. We'll talk about what that means for the weather back home in the US, Missouri, Illinois, DMV, other parts of the United States. I'm also going to talk about New Zealand. So if you are curious about the New Zealand impacts, I'd say scroll through the end of the video. El Nino is an unusual warming of waters in the eastern Pacific. It was noticed more than a couple hundred years ago by fishermen off the coast of Peru and Ecuador. Now it is a known meteorological and climate feedback that occurs every few years. And what's significant about El Nino is it has a large impact across the world, not just here in the Pacific Ocean and about places like New Zealand where I live now, but all across the world. It can impact the weather in the United States, across the rest of the Americas, Europe, Africa, the Indian monsoon, Australia, parts of Asia, everywhere. So NOAA officially declared El Nino back on the 11th of June. The Japanese Meteorological Agency did a few days before that, and this is from the Bureau of Meteorology. They have also officially declared El Nino as of the recording of this video just a few hours prior. Let me go to the full screen. You can see we are firmly in El Nino territory according to the Southern Oscillation Index, one of the many indices that we use in the science world to determine whether an El Nino has happened. We also look to see if the atmosphere has responded. We look at sea surface temperatures. We look at the temperatures of the ocean at depth as well, and pressure differences across parts of the world. I'm not going to explain all that in this video, but I'm going to talk briefly about some of those elements, including that sea surface temperature anomaly. And let me scroll back. We're going to go back to the beginning of this video here. This is from NOAA Coral Reef, and watch as it starts over, okay? So you see that blue blob? That was the departing La Nina that we just came out of. We went to what is called El Nino, ENSO neutral, I should say, for a few months here earlier in 2026. And now June, officially, El Nino has been declared by several meteorological agencies, and that's that warming of water. These are temperature anomalies at the surface. You can see sea surface temperatures were really warm in this section of the Pacific Ocean. And essentially, the warm water spreads in from underneath the surface of the ocean and also spreads in from the west on the heels of what we call westerly wind bursts. And these westerly wind bursts push the ocean water eastward. So normally it's cooler here in the eastern Pacific and warmer in the western Pacific because of the trade winds. The trade winds are all what drives these warmer temperatures. What happens is the trade winds, they weaken and sometimes they reverse, and that warm air spreads eastward. So does the warm water. We also get what we call waves in the atmosphere that also help push that warmer air and the warmer water eastward. So what does El Nino do? It has a knock-on effect all across the world. In fact, you can see it here on this graphic. And you could see it can bring drought to the Philippines, Indonesia. We call that the maritime continent there, down through Australia, even here in New Zealand. It can bring some dryness to the Pacific Northwest and other parts of the Midwest, but also a wetter signal for Southern California down through the Southwest, the American Southwest, Texas, over to Florida and other parts of the southern states, and even over to the DMV. It could bring or shut down the monsoon, bring dryness, or completely shut down the monsoon, really, by normal standards in India. It brings wetter weather in parts of Africa, but other parts you see dryness. So it has a knock-on effect all across the world. This is a phenomenon that's natural. It has occurred for hundreds, potentially thousands of years, well before we defined it as human beings. But of course, like all things, it is being impacted by global climate changes caused by human impacts. We're not going to talk about climate change and the warming world right now. We're just going to talk about El Nino and how it can impact us in the United States and across New Zealand. So there's that wetter weather that this is a typical El Nino map. It doesn't always happen like this, but it gives you an idea. There's usually a drier signal for my friends back in Missouri and Illinois. Wetness can extend up into the DMV, though, as the southern branch of the jet stream, mainly in the winter, amplifies and gets stronger. And that's what could lead to those horrific floods sometimes in parts of California, Arizona, even into Texas and parts of the American South. Florida and parts of the Carolinas as well. Tends to bring mildness to the upper parts of the United States, and the Pacific Northwest can be mild and dry in the winter as well. Can be, not always, but often is in these El Nino events. And again, the jet stream, it's amplified by that warmer water that is originating in the Western Pacific, having moved east across parts of the Pacific. So why does this all happen? Well, the atmosphere normally has a circulation called the Walker circulation. Okay, so this is what it looks like during normal neutral conditions. I say normal, this is a generalization. It's not exactly how it is every single day of the year, but in general, you get rising air over the maritime continent, thundery downpours there, lots of wet weather. Those are tropical places. Meanwhile, in the central and eastern Pacific, you get subsidence or downward moving air. High pressure brings generally quiet weather. That's what you usually get in between El Nino and La Nina. What happens during El Nino, again, this Walker circulation is displaced. And what happens is the rising air moves over to the central and eastern part of the Pacific. Now you've got air that is sinking over the maritime continent and brings drier conditions across Philippines, Indonesia, Malaysia, down through Australia, and sometimes over to us over here in Aotearoa, New Zealand. You get additional storminess in the central and eastern Pacific, and some of those storms, they break off and move into North America. That's why the American South, Southern California, Southwest U.S., and the southern parts of the United States get more active weather. You can get wetter weather, especially in the winter time there. Not as much of a signal in the summer, but in the winter time there is when you get the biggest impacts. So this is what happens in El Nino. You can see that easterly component to the wind, or should I say westerly component to the wind. Again, let's go back to neutral. That's the trade winds. We go back to El Nino, and you can see that westerly wind burst, those westerly winds pushing the warmer water from the Western Pacific over to the central and eastern Pacific. So you get a pooling of the warmer water where it's not normally warm, and that's why you get that additional storminess as well. Here you get a slight cooling later in the El Nino cycle, which is due to the upwelling that could occur here when you're throughout the ocean. Okay, we're not going to talk much about the ocean. That's not my area of expertise per se. One thing I do want to note, it also has an impact on the Indian Ocean dipole. In fact, the strongest El Ninos will generally force a positive phase, and that can create a feedback cycle as well across the Indian Ocean, increased thunderstorms and convection across the Western Indian, and again, more of that dryness or subsidence in the eastern part of the Indian Ocean. Again, that reduces the rain chances in Australia and oftentimes New Zealand as well. This is important because when you get a strong positive Indian Ocean dipole or IOD, it tends to reinforce the El Nino and makes it stronger. And part of the reason why it could be a super El Nino, we'll talk more about that momentarily, is because of the potential positive phase of the Indian Ocean dipole. It's not positive right now, but it is forecast to become positive from the Bureau of Meteorology. So what is a strong El Nino? Well, it's a very strong El Nino. So weak El Nino is essentially about either 0.5, 0.7, or 0.8 degrees to 1 degree above normal in that part of the ocean that warms up the central and eastern Pacific. We look specifically at an area called the Niño 3.4 region in the United States and here in New Zealand as well. When you get a strong El Nino, that's when you have temperatures above that 1 to 2 degree anomaly in that part of the ocean. Above 2 degrees, that's very strong. That is the definition of a super El Nino. Think about the years of 82, 83, 97, 98, 2015, 2016. The strongest El Ninos were all 2 degrees above average in that portion of the Pacific Ocean. Those were super El Ninos. Now, the official meteorological agencies do not use that term, but it is a real term. It has been studied. It is in the literature. You can look it up on Google Scholar. It exists. It is a real term. It's not made up. Scientists have used the term, but in general, forecasters across the world use the term weak, moderate, strong, or very strong. So there are forecasts pointing to a very strong El Nino, potentially the strongest ever recorded. It doesn't mean it's the strongest we've ever seen, but certainly the strongest ever recorded. And I'll show you that in the forecast coming up. What are the impacts? I'm glad you asked. Well, this is the June, July, August precipitation outlook for the continental United States. And it does have Alaska on here too, but let's focus in on this. Not a strong signal, perhaps an enhanced monsoon as far as rain chances, but overall the summer is not looking super wet or super dry across much of the United States, especially in my hometown in St. Louis, or up into the DMV is where I used to live. Pacific Northwest, another place I lived in Oregon, there is concern for dryness, and that could potentially be related to El Nino. But just keep in mind, El Nino, La Nina, and so it is not the only driver of our climate and weather. And again, remember, climate, long-term weather is what you get every single day, every minute, hours, day of the week. Temperatures are looking warm, but this could be a myriad of factors. But check this out. This comes in from Ben Knoll's page. Shout out to Ben Knoll, who used to work where I currently work now, Earth Sciences New Zealand. He works for the Washington Post. Does great stuff there. Check out this. This is his super blend from his page, okay? So credit to his page. I'm going to go full screen on this. And this is the September to November time period. So fall, almost winter. And there is a wetter signal on the European plus UK Met seasonal forecasts blend of ensembles. So a wetter signal here could be indicative of that developing El Nino. At this point, we could be moving into a very strong El Nino. So the jet stream becomes quite active. You start picking up extra moisture from the central and eastern Pacific, and then that gets driven in through the jet stream in the form of atmospheric rivers and other storm systems and moves across the southern United States. So this could be a wet signal because of El Nino. And if you look at the Climate Prediction Center forecast for the winter months, December, January, February, there is a clear signal here of wetter than average weather, or at least a better chance of wetter than average weather from the DMV down through Florida, Georgia, and over towards Texas, Louisiana, back into the Southwest, I should say, Southwest United States, and perhaps even in Southern California. Again, this comes from the Climate Prediction Center, part of the National Weather Service. So generally wetter in the American South and over the DMV. Back in where I am from, back in Missouri, Illinois, could be a little bit on the dry side. Temperatures, too, also reflective of that potential storminess and active weather for the American South, too, during an El Nino winter, December, January, February. This, again, comes in from Climate Prediction Center. Note, it was issued on the 21st of May, so there will be a new update to this here in the days to come. So check them out if you can. But this would be a clear signal of El Nino's influence. Stormier, more active weather, better chances of near normal or below normal temperatures. No guarantee. When they say equal chances, it could be on either side. There's no clear signal, but certainly a signal of something happening there associated with the temperatures. Meanwhile, the northern tier of the United States looks warmer than average, and that's probably going to be less stormy as a result of the jet stream moving in from the south and west. Not a guarantee, though. Weather's fickle, man. You can get a really big snowstorm, rainstorm in the middle of a dry period, and that could help bust your drought, or at least make it less dry, if you will. Okay, last thing I want to show you is back here in New Zealand. For those who are wondering, maybe you've stuck through the entire video, you're wondering, how does this impact us here in New Zealand? I'm going to go full screen again with the graphic. This is what we call an analog. It shows you El Nino years, 1972, 77, the big 1982 El Nino, 93, 94, 97, 98 El Nino, and 2014, 2015, just to name a few. And we've combined all of these. You can find this on the NIWA website, Earth Sciences New Zealand. NIWA is our old name. And just concentrate on this right panel here. El Nino tends to be drier across most of the country, especially Canterbury, parts of Otago, but even up into the North Island as well. There is a little bit of a wetter signal. Southland, maybe Clutha, and down through Fiordland, Stewart Island, tends to be wetter. This is not a forecast. This is just in general what past El Ninos have done. So expect El Nino to possibly behave similar to that. We'll have our official forecast on the Earth Sciences New Zealand website. We put out a forecast every single month, so check that out. I highly encourage that if you're wondering about the New Zealand climate and weather forecast in the long range. Okay, well, that's all I have to say about El Nino today. There's a lot I did not cover. I will try to talk more about these things in the months to come as we head towards this potential super El Nino. There are a lot of things that occur with El Nino that I haven't talked about. The fact that we could end up seeing the hottest temperature on record because of El Nino and some of the other impacts that occurred too across the world. But for now, I'll end the video here. Thanks for joining me. I'm meteorologist Chester Lampkin. Stay safe out there, and thanks for watching.